Hello class, welcome back. This is ME 354, lab number 3. Today we're going to be studying the shear response by applying a torsional force, these long slender rods here. The materials will be A36 steel and 6061 T6 aluminum, just like in the previous labs. To do that, we're going to use this fixture here. The fixture has two grips at the top and the bottom. The specimen is gripped between the two. The lower grip can be rotated continuously. The upper grip works against a lever arm that reacts against a load cell. The load cell can be read out here in this digital display. Our angle of twist will be measured in small increments to start with, and then throughout the test we'll increase those increments until the specimen eventually fails. All that information will be recorded in this table here, which you'll receive in an Excel format. All right? So I'll go into a little more detail about the fixture and how we do the test, and then we'll go ahead and break our specimens. Let's take a closer look at our test space. We've got our grips below and above. These are basically drill chucks that you would find on a drill press. 3-jaw chucks. The specimen is slid in from above and tightened up here using a chuck key, just like you would on a hand drill or a drill press. The lower grip can rotate in a clockwise position, and so we take this arm and advance our drill chuck in a clockwise position, applying a torque to the specimen. When we release the arm and go back for another grab, the chuck is prevented from rotating counterclockwise. That way we don't lose all of our torque. So how are we going to control this angle of twist? Well, for the first 45 degrees, we want way more than one measurement, so we're going to measure at the 2-degree level from 0 to 45 degrees. To do that, we have this threaded rod attached to the arm here. As I rotate it, it's going to rotate our grip. If you look at the bottom of the screen, we have a scale and a pointer, and I can very precisely control that angle of twist to the 1-degree level. In our case, we're going to go 2 degrees, stop, take a reading, write it down, 2 more degrees, stop, take a reading, write it down, and so on. Now, it would be great if we could do this all the way along, but we have thousands of degrees of rotation, and obviously we can't go more than about 50 degrees with this system. So we will go to 45 degrees, and once we get there, we're going to rely on our 45-degree incremented cogs on our lower grip. So once we get to 45 degrees, we should hear a clicking sound. That means that we've gone to the next cog. Should be coming up. Okay, there's our click. So now I'm going to rotate this guy and release this threaded rod. Completely remove it. Here's a closer look at the lower grip. You can see there's a cogged wheel at the bottom here, and this arm can move independently of that. There's a spring-loaded finger on the arm that catches the cog as I rotate it clockwise. I can let go back for another grab. There's another cog at the back here that prevents my chuck from rotating counterclockwise. So I can advance it, take a reading, release without releasing the torque, grab another one, click, release without releasing the torque, and so on. As I said, each cog is 45 degrees apart. If I want to go 90 degrees, I just take 2 clicks. If I want to go 180, I'll go 4 clicks, and so on. So once we pass 45 degrees, we're going to be using this method of just counting clicks and writing down the angle of twist in 45 degree or 90 degree or 180 degree increments. All right. So this is a view of the fixture from above. In the center here, we have our upper grip. Connected to the upper grip around the perimeter are these 2 cables. One of the cables is fixed to the machine frame here. The other cable is fixed to this lever arm. We have a fixed pivot point on one end of the lever arm, and the other end, the lever arm is free to work against this load cell here. So as I rotate the barrel, I apply tension to the wires and I get a readout down below on the display. The readout is in kilograms, so you need to convert that into newtons. And those readings, combined with the geometry spelled out in your handout for this lever arm system, will allow you to calculate the torque that's applied to the specimen. Okay, I think we're ready to load up our aluminum specimen. First thing I want to do is lay it down here and take a Sharpie. I'm going to draw a line parallel to the axis. So that we have a reference of where we started. So we'll grip it at the bottom, grip it at the top, and as we rotate, we'll start getting a spiral appearance from this red line. I'm going to drop it into the grips now. I'm going to tighten the lower grip first. I'll take all the slack out of the top, tighten the top grip. Nice and tight. We don't want them to slip. All right, great. Now while I've got the specimen supported, I'm going to measure the diameter and record that in my table. All right, we're ready to start taking data. We've got our specimen installed, all the slack out of our system, our load cell is zeroed out, you can see on the display there, and our pointer is at 0. We're going to be taking data the old-fashioned way by actually writing it down in this table here. So I've got my angles already written out from 0, 2, 4, and so on. Once we get past 45, we're going to do four increments at 45, then 4 at 90, 4 at 180, and then finally finish up at 360 until it fails. So for each increment, I'll write down the force. So let's get started. First increment is 2 degrees. My force reading is 0.15 kilograms. My next reading is 4, 0.26. My next reading, 6, 0.405. And these will continue on until we get to 45 degrees. Okay, we're approaching 45. Because of the little bit of backlash in our system, we probably won't get a click until we're a little bit past 45, but I'm going to take a reading here. And now I'm just going to keep going until I hear my click. There it is. And now I'm going to back off my threaded rod and get ready to do the larger increment starting at 45 degrees. So now I'm just going to grab the rod and rotate it until I hear a click. I'm going to hold there and look at my load reading, 3.830. As I release, there's a little backlash, so it's going to drop. So I want to record my reading at this peak here, 3.835. That's my first 45. Go back and grab another one. Bring it forward. 4.0. Another 45. 4.095. Another 45. 1.17. And now I'm going to increase my increments to 90 degrees, so I'll go 2 clicks. So there's the failed specimen. Pull the top section out. Okay, so the steel specimen is done exactly the way the aluminum specimen was done. There's not a whole lot new to see, but I'm going to load it up and test it. We'll fast forward through most of that. Okay, here we go. Here's a close-up of the fracture surfaces of the steel and aluminum. So there's another angle of the fracture surfaces, the aluminum on top, the steel on the bottom. And that's about it for this lab. We've got our data collected for the steel and the aluminum, and you'll receive a version of this in an Excel format. All right, good luck.